You are welcome to lesson 4. And lesson 4 is actually a continuation of lesson 3. So we are still learning how to add and subtract multiples of 10 and some ones within 100. However, in this lesson, we are going to learn a new strategy of adding and subtracting. A very beautiful simplifying strategy that makes math fun. Are you ready? Alright, but let's begin with some fluency practice. Okay. Now, what digit is in the tens place in 174? What digit is in the tens place? Is it 1? Is it 7? Is it 4? Alright, we have 7 in the tens place. Okay, so what is the value of 1? Good, it's 100. And what's the place of 4? It's 4 ones. Good. I can see you're ready for the lesson. Alright, now check out this. What digit is in the tens place? 258. What digit is in the tens place? Good, it's 5. But what is the value of 8? It's 8 ones. And the place of 2 is what? Hundreds. Okay. Alright, let me check it up a little. What digit is in the hundreds place? What digit is in the hundreds place? Do you have your answer? Oh, good. 7. 7 is in the hundreds place. And the place value of 4 is what? 4 ones. And what's the place of 3? 30. So we have 700, 3 tens, and 4 ones, which is 734. Alright, now, what digit, again, is in the hundreds place? I have 860 on your screen. What digit is in the hundreds place? Exactly, 8. 8 is in the hundred place. The value of 0 here is 0. And the place of 6 is tens. 6 tens. 800, 6 tens. Okay, lastly, what digit is in the ones place? What digit is in the ones place? I have 902, 902. What digit is in the ones place? Good, 2. 2 is in the ones place. All right. And the place value of 9 is 900. And the place of 0 in this question is 0 tens. No tens. Okay. Well, let's find the missing parts to make 10. So if I say 6, you say 4. Then say the number sentence. Okay. So for every number I call, you're going to tell me what should be added to that number to make a 10. Alright. Now look at something. 6. And 6 plus 4 is what? It's 10. So when I call a number, you tell me what should be added to the number to make a 10. Okay. Now, let's get fully started. 16. What should be added to make a 10? It's 4 also, because 16 plus 4 is 20. Alright. What about 23? What is needed to make a 10? Good, 7. So 23 plus 7 is what? 30. Now, are you ready for the next one? Now we want to make a 10 by pulling a number from one side to build the other side. I said we're going to learn some wonderful strategies for addition and subtraction. Now watch what I'm going to do in this question. 9 plus 4. 9 plus 4. Now, here's my strategy. I'm going to break 9 plus 4. I break 4 apart because 9 is closest to 10. Here, 9 plus 4. 9 is closest to 10, and it needs just 1 to become 10. It needs just 1 to make it 10. So I'm going to pull 1 away from 4. So instead of saying 9 plus 4, you say 10 plus 3. Because I've taken 1 away from 4 to make a 10. So 9 plus 1 is 10, and what's left is 3. So 10 plus 3 is 13, which means 9 plus 4 is the same as saying 10 plus 3. Okay, let's try 8 other numbers now. I believe you understand what I just did. Now 49 plus 4. What will you do? Good, that is 50 plus 3. Pull 1 away from 49 and it gives us 50. Okay, now 19 plus 6. 19. 9 is also very close to 10. It's closer than 6. So I'm just going to pull 1 away from 6 to make a 10. And that gives me 20 plus 5, which is 25. Okay. It's easy to make a 10. 48 plus 3. What should I do? 8 needs what? It needs 2 to make a 10. So pull that 2 away from 48 and it will give you what? 48 plus 2. That's 50. And you are left with 1. So 50 plus 1 is 3. So 48 plus 3 is 51. $88 plus 5. What should I do? Good. Break down 5 into 2 and 3 because 88 needs 2 to make a 10. So when I break it down, I will have 88 plus 2, which is 90. Then 90 plus 3 is 93. Alright, that's done. Now here's 5 blue linking cubes. And below it you can see some green cubes. Now, how many blue and green do we have here? I have 5 blue, I have 3 green linking cubes. So what's the difference? I'm asking, what is 8 minus 5? And the answer is in the green cubes, which is 3. Okay, now we want to do a little something with this. Something has been added to both sides. You can see the orange linking cube added. Now we have 1 orange and 5 blue on top, and below I have 1 orange, 5 blue, and 3 green. Okay, has the difference changed? In our first one, we add what? 8 minus 5, and the answer is 3. Now, 1 has been added to both sides, giving me what? 9 minus 6, and the answer is still 3. So the difference didn't change. Okay, now what I'm trying to tell you is, when you add the same number to both sides of a subtraction problem, you will get the correct answer. Okay, how do we use this knowledge? Let's see. When we add the same amounts to each number in a subtraction sentence, the difference stays the same. Alright, I want to test this idea by solving 34 minus 28. Okay, 34 minus 28. Oh, that's challenging. Now I'm going to look at the ones. 34, that's 4 ones. 28, that's 8 ones. Between 4 and 8, which is closer to a 10? Good. 8 is the closest to a 10, and it needs 2 to become a 10. Because it needs 2 to become a 10, I'm going to add 2 to both numbers. Okay, so it's going to be like this. 34 plus 2. 28 plus 2. So 34 plus 2 is 36. 28 plus 2 is 30. Now the reason I'm bringing my number to a 10 is because it is easier to subtract when the numbers are in tens. You just subtract the tens and you get your answer. Okay, so instead of me thinking of 34 minus 28, which is challenging, I am solving 36 minus 30 and the answer is 6. So 34 minus 28 is 6. See? The rule says when we add the same amount to each number in a subtraction sentence, the difference stays the same. That is the rule. Okay, now your turn. 22 minus 8. 8 is closest to 10. So, and it needs 2 to become 10. So, you will add 2 to both sides, which means you are actually solving 24 minus 10. You can make a tape diagram and add to both numbers to make the problems easier. 26 minus 19. Between 6 and 9, who's the closest to 10? Yeah, you're right. It's 9. And what does 9 need to become a 10? It needs 1. So you're going to add 1 to both sides, which means instead of thinking about 26 minus 19, I'm actually thinking about 27 minus 20. 33 minus 18. Same strategy. Look at the ones and work it out. Alright, now I have 6 blue cubes on one end and 4 blue cubes on the other end. 6 blue cubes on one end and 4 blue cubes on the other end. But in between them, I have 1 orange in the middle. So what's the total? Okay, it's 11. So I have a total of 11 linking cubes, don't I? All right, now let's see something. Now, I want to make 2 different addition sentences. All right, you can see the first addition sentence up there. I have 6 to one side and 5 to the other side, which is 6 plus 5 is 11. Below it, I'm having 7 linking cubes to one side and 4 linking cubes to the other side. That also means 7 plus 4 is 11. Okay, what do we need this knowledge for? All right, I'm going to show you something. I have 19 plus 35. 19 plus 35. Quick thinking, I need to think of how to make it a 10. How do I make it a 10? I will look at 19 and 35. I look at the ones and just work with the one that is closest to 10. And obviously, between 9 ones and 5 ones, the closest to 10 is 9 ones. So, what does 9 need to become a 10? It needs just 1. Like we did in our fluency practice, I will pull 1 away from 35 and add it to 19. So instead of thinking of 19 plus 35, which is challenging, I'm actually thinking 20 plus 34. So my answer is 54. Okay, another one, 78 minus 24. A quick look at this. 8 is closest to 10 than 4 ones. So I'm going to pull 2 away from 24 because 8 needs 2 to make a 10. So instead of me thinking of 78 plus 24, I'm actually thinking about 80 plus 22. You see that? 78, and the 2 in the middle is a 2 I pulled away from 24. And of course, I've taken 2 out of 24, so I have 22 left. 78 plus 2 is 80. 80 plus 22. Yeah, that is 102. Do you understand this strategy? It's a very simple strategy. Now let's test it with this application problem. Carlos bought 61 t-shirts. He gave 29 of them to his friends. How many t-shirts does Carlos have left? He bought 61 t-shirts. He gave 29 of them to his friends. How many t-shirts does Carlos have left? Alright, so my number sentence is going to read 61 minus 29. 61 minus 29. Now, following the strategy we've been learning, 9 is closest to a 10 than 1. 9 needs just 1 to become a 10. So I'm going to take 1 and add it to both numbers. So now I'm having 61 plus 1, 29 plus 1. And 61 plus 1 is 62. 29 plus 1 is 30. It's easier for me to subtract 62 and to subtract 30 from 62 than thinking of how to subtract 29 from 61. And 62 minus 30 is what? 32. You don't need to think too far when you're using these strategies, because once you add to the numbers, but remember, when we are subtracting, we add to both sides. When we are adding, we take from one side to make a 10 on the other side. Do not confuse both strategies. When we are adding, we take from the ones to complete a 10 on the other side. But when we are subtracting, we add the same number to both sides. Okay, that is it. I want you to use the instruction and the strategy you've just learned to solve lesson 4 problem set. The first round of questions are subtraction problems. 23 minus 9. Of course, 9 is closest to 10 and it requires just 1 to be a 10. So we're going to add 1 to both sides. It becomes plus 1 plus 1. So that will give us 24 minus 10. Okay. Now I want you to run through all of the problem sets of lesson 4 and let's see some addition problems in lesson 4. 29 plus 46. That is 30 plus 45. What happened to it? 9 is closest to 10. So I have to drag 1 away from 46 and add it to 29 to make 30. And what is left of that 30? I just have to add up 30 and 45. Because 46 has dropped 1 to make 29 30. So it's now 45. Okay. Now do the same for all of the questions in number 2. And then let's go over the lesson. How did you label your tape diagram in problem 1B? And why? Share your tape diagram for problem 2B with a partner. How did you label it to add tens? Look at problem 2C. 61 plus 29 is equal to 60 plus 30. Is this true? How do you know? What other special strategy could you use to solve problem 1A to D? How could you use the arrow way to solve these problems? What do you notice about the numbers in the problem set today? And lastly, when is the best time to use the tape diagram to solve? What is the goal in using the tape diagram as a simplifying strategy? Until I come your way again, it's Mr. T saying, remain mathastic and keep rocking in maths. Bye for now.